So what's special about a Cartesian coordinate system? Well, the first thing is that let's start out. So these are always orthogonal axes. So in general, although it's not really absolutely required, but in general, this axis would be considered is called the x-axis, and the vertical axis in general is called the y-axis. Okay, so that's the generic standard thing that people do, although in some cases you do interchange the axes and call the vertical axis x-axis and the horizontal axis y-axis, but mostly it's the way I have shown it to you. Then there's an origin, so we put the origin right here. So this is the origin, which is 0, 0. So there are two coordinates here, 0. And then I just have a number line. So this is 1, 2, 3, 4, 5. And I'll have a -1, -2, -3, -4, -5. And similarly on the y-axis, I'll have again 1, 2, 3, 4, and it goes on. And below the x-axis, I'll have -y, -1, -2, -3, -4, and it goes on. Okay, so both of these obviously go on forever. So now if I want to locate a point, let's say I want to locate various points. So let's say I want to locate a point 2, 3. So what that means is that its perpendicular distance from the y-axis is 2. So I'm going to move 2 units perpendicular to the y-axis. So these are 2 units perpendicular to the y-axis, and they have to be on the positive side because this number is +2. And then I have to walk 3 units away from the x-axis, and again in the upwards direction because it's a +3. So I'm 2 units from the x-axis and 3 units, as you can see, I go 3 units from the y-axis, so from the x-axis, and I get to this point. So this is the point A, which is the point A is 2, 3. Now I can also locate another point, maybe which is 2, -3, which is the point B. So 2 minus 3, again what that means is that the distance from the y-axis is again going to be +2, and +2 because 2 is a positive number. But the distance from the x-axis is going to be -3. So I have to go down, okay? So I'm going to go 2 units. So I'm going to go 2 units to the right of the y-axis, and then I'm going to go 3 units below the x-axis. So I'm going to go 3 units below the x-axis. This is 2 also units away from the y-axis. So this point is going to be B. Now I can try to locate another point, which is maybe C, which is, let's say, -2, -3. So now please note that the distance from the y-axis is -2. So that means I have to go to the left of the y-axis. So this direction is to the left of the y-axis. I have to walk 2 units to the left of the y-axis, and then I have to walk 3 units below the x-axis. So if I walk 2 units away and 3 units, so this is going to be the point, which is going to be C, because you can see this is going to be -2, and this distance right over here, this distance is -3. So this is going to be the point -2, -3. We always state the distance from the y-axis first, and then we state the distance from the x-axis. Okay? So please note that these coordinates are a very special kind of tuple. It's an ordered tuple. So these are ordered tuples. So and you might have seen ordered tuples in other places as well. Maybe you can think of something in Python. There's a data structure called a tuple in Python, and that's an ordered tuple. You've seen latitudes and longitudes that are ordered tuples. But the particular thing about Cartesian coordinates is that the axes are two axes are drawn, they're perpendicular to each other, and the coordinates are given by the perpendicular distance to the axes. So that's what defines a Cartesian coordinate system. And you can, just to remind you, that the reason why they're called Cartesian because they come from Descartes. So here's Descartes, and you can see that there's right over here, there's a cart that is coming from Descartes. Okay, so this is the reason why it's called a Cartesian coordinate system.